Here we have a quadratic equation, so we can see if we can maybe solve this by factoring. And since we have no leading coefficients, it should be easy to factor if it's factorable. So I'm looking for two numbers that multiply to -2 and add to +5. Well, there's no whole numbers that do that, so this is not factorable. But although it's not factorable, we still have the quadratic formula, so we can solve using the quadratic formula. So I'm just going to put it in. So it's going to be negative b, so it's going to be -5 plus minus the discriminant. It's going to be b squared, so it's going to be 25 minus 4 times a times c, which is negative. Now be careful of your negatives here. We're going to end up adding those two terms since it's a minus a negative. So in the denominator, we're going to have divide by 2. So -5 plus minus the square root of 25 plus 8. And that's going to be all over 2. And then we can simplify that to -5 plus minus the square root of 33. That is not a perfect square. So again, that's another indication that that is not factorable. So our solution is going to be that in its exact value. So -5 plus root 33 divided by 2, -5 minus root 3 divided by 2. So if we need a decimal value, we can work this out. But otherwise, unless a decimal value is needed, we're just going to leave our answers like that. So for this next one, we are going to solve a radical equation. Now we have to be careful of our extraneous solutions. So I'm just going to first of all state our domain, and we're only going to worry about the inside domain. Although there is an outside domain, we're not going to worry too much about that. So x is going to need to be bigger than or equal to 3 over 2. Okay, it's always the back divided by front, the opposite sign. So that's our domain. We need to solve this by getting rid of the square root. So we undo the square root by square, and then we need to square this side. When we undo the square root, we're just left with 2x minus 3. When we square this side, we have to remember that we can't square across the negative, so we have to multiply or distribute this out. X squared minus 2 gives me minus 4x. -2 times -2 gives us plus 4. So we have a quadratic equation here, so we're going to make this equal to 0. So x squared minus 6x, subtract 2x from both sides, add 3 to both sides, we're going to get minus or plus 1. Oops, no, that's not correct. We're going to add 3 to both sides, and we're going to end up with plus 7. Now this is factorable. There are two numbers that multiply to 7. This is not factorable. So we're going to have to solve this using quadratic formula. So plugging this into the quadratic formula, I'm going to end up with x is equal to negative of -6 plus minus -6 squared is going to give me positive 36 minus 4 times a times c. So we're going to subtract here. This is all going to be over 2. So I end up with 6 plus minus the square root of 36 minus 28 is going to give me 8. That's all over 2. And we can simplify this to 6 plus minus root 8 becomes 2 root 2. We'd factor the perfect square 4 out, which becomes 2 on the outside. We end up with this expression, and that fraction can be simplified with a ratio of 2. So we get 3 plus minus square root of 2, and there is our solution. Now, because it's a root, we should really check to see if this works. Okay, so this number is about, the decimal number is approximately 1 point, I'll work this out. Okay, it's going to be 3 minus root 2 is 1.59. And that fits in the domain of bigger than, it's going to be bigger than 1.5. And then the other solution here is going to be 3 plus root 2, which is about 4.41. Now, because there's an outside domain, we have to be a little bit careful in that one of these is actually still extraneous because this is not a complete domain that we've given here. So this only represents an outside domain, inside domain. It doesn't actually reflect the outside domain. There is an outside domain based on this term here, and it actually is greater than 2. So this solution is actually extraneous. Now, if we're not sure about that, again, we should check it by, we need to check this solution for extraneous solutions. So if I check, so I'm going to do a check here. X equals 1.59, and we're going to get about 2 times 1.59 is about 3.2, minus 3 is square root of 0.2, and that's going to be equal to negative 0.4 approximately. Okay, so that does not work. Okay, so these are not, this is not equal to each other, so this is actually extraneous. And then if I check x equals 4.41, we're going to end up with, that's going to be about 8.8 minus 3 is about square root of 5.8. 4.4, yeah, minus 3. And on this side, we're going to end up with 4.41 minus 2, which is about 2.4. If I square root 5.8, I get about 2.4. Okay, so this is okay. So this solution is perfectly good. So the solution is going to be x is equal to 3 plus root 2. This is our valid solution. 3 minus root 2, this is extraneous. Okay, so we do have to check these. These are a little bit hard because these roots are not exact, number one, and also the decimal values are a little bit harder to check, but we can still estimate and see that these are in fact, the first one doesn't work, it's extraneous. The second one does work, it's not extraneous. Now, if we want to, and this is not something that we expect you to do in grade 11 math, but this issue of this outside domain does allow us to complete the domain. So to have a complete domain, the domain would also have to pass x is greater than or equal to 2, and that outside domain then confirms the extraneous solutions and the valid solutions that we ended up getting.